Yeah, so welcome to RF and millimeter wave class, and in this small video what we will do is I'll demonstrate how you can perform a simulation on LTspice. So this is a window where I have actually opened a new schematic here, and maybe I'll just close the other. Yeah, I'll open a new schematic, and what I'm going to do now is I'm just doing the matching network of L match to transform an impedance of 50 to 25. So the circuit what we have is you have a resistance. I'm picking a resistance from here, and this resistance of the value of this resistance is 50. I need to transform this into 25. For that I am using an L match. So the L section is of this way. You have a capacitor here, you are getting an inductor. Just to rotate, you can use the control plus R to get it rotated, and this is the L section, right? So just for connection, you can take this wire, click on this wire, and you can do connection like this from here to here. And
so how did you rotate it?
Control plus R.
And then click on the component?
If you for the wire you are asking?
No, sir, for the component L1.
Okay, so what I'll do is, see, I just clicked on the inductor, and now inductor is there. I want to do rotation, right? So I'll just do control plus R. So it is rotating. I want the other form. So I'm just 3 times doing control plus R, and then I'm just keeping it there. That is by left click. Now I'm just removing that. Just to remove, you can take the scissors and you can cut it. Okay. Or even you can use the delete button on your keyboard. Now this is the resistance R and L match here. So what I need to do now is I need to add a voltage here, so that I'll go to the component. In component you have this voltage. This is the voltage available. I'll take that and I'll keep it here. If you want to move the component, you can use the option move. Yeah, now so after doing each operation, you can press the escape button, so that that specific operation will not be there after that. So again, I'm connecting this wire from here to here. Yeah. The connection is done, and LTspice also always asks for a reference point of ground. So I'm just clicking on this ground point and I'm keeping it here. Now the circuit is complete. Now we need to give the values. So the values can be entered here. You can right click on this R, C and L, and there you can enter the value. So the value of R is 50 ohm. So I'm entering it as 50. Then the value of C is, in the class what we have done is 0.63 picofarad. It is 0.63 pico. And the L value is 0.79 nano. So this is 0.79 nanohenry. That is done. So the resistance and the L match is ready. Now look at the voltage source. What we need to do here is we'll perform an AC analysis, and we will plot. Sorry, we'll set up this voltage first. So what I'll do is I'll just go to advanced, and I'll set the AC amplitude as 1. That is the only thing what I'm going to do. I'm not taking any functions. I'm not introducing any DC value. Just I'm keeping the AC amplitude as 1, and I'm just leaving it. Right. Now
so how do you go to advanced?
Yeah. So right click on this component. You will directly get this. Or if you right click on this, sorry, not here. Yeah. When you do right click, you will directly get this.
Okay, sir. Thank you.
Okay, yeah, that's it. Now so the circuit part is ready. You have entered all the components. Make sure that you have to you don't forget to keep this ground reference point here. This means that the AC amplitude is 1. Now you can just save this, and you can go to simulate, where there is an option called as edit simulation command. Click on that. There you will have a lot of analysis. I'll just click on AC analysis. I'll do the type of sweep as decade. the number of points. You can enter some points as 100. I'll do start frequency. Now this example is designed for 5 gigahertz. So I'll just start from 1 giga and I'll go up to 10 giga. So you can see this is the command AC analysis. Decade is the type of sweep, 100 points per decade. Variation is from 1 giga to 10 giga. So, and after clicking the OK, you will get the command. You need to place the command by pressing the left button on the screen. That's it. Now you can directly go and click on run. So that will give you a blank window to the top, and you can see this. What is this? The circuit schematic bottom. Now, what I want here is I want to know what is the impedance seen from the input side, right? That is what we do with an L match. So if I want to find the impedance from this side, basically what I'm going to measure is the S11 parameters or the Z11 parameters on the input side. So I need to know what is input voltage and input current. So what I will do is I'll just right click on this blank screen. There is an option called as add traces. And in that you will have the voltage and current of, there are a list of variables or the data available. Now you need to know what is the input voltage here. Right, so you want to know. I didn't keep any label. If you want, you can actually keep a label. That is better. So I'll just introduce a label here. V in, and I'm keeping this as input, and I'm keeping the label here. And let me see, will that make any difference? So in the traces, yes, I'm getting V. Yeah, so I'll get the voltage here. That is V of V in. What I need is resistance. So this divided by the current of V1, I of V1. That is the current of V1. So what I am, the expression what I added here is V by I, which is nothing but the impedance seen from this side. If I click on OK, you will get this waveform. I'll just right click on this phase plot, and I will just click on this. That is, I'm not plotting the phase, but you can see now the magnitude plot here. But what I want to see is the input impedance. It should be on ohms. Or your left hand side or your y-axis is now in dB. So I'll right click on that. I'll keep the representation to linear, and I'll click OK, so that you will get the resistance value here. Right. So what we designed is at 5 gigahertz, your impedance should be 25 is what we designed. So in order to get a trace, I'll just click on this so that a trace will be coming up with a pop-up window. And if I move this trace, I will get the value at 5 close to 25.01978 ohms. All right. Is this clear? Any questions on this?
So how do you enable the trace, sir?
Yeah, so to enable trace, so you have the expression on the top, right? I'll just left click on this. If I click, you will get this trace along with this window. And left click on this and just drag it so that you can read any value.
Okay, sir. Got it.
So
Right.
could you tell how you added the label and then how did it reflect in the blank window and how you simulated that one part?
Sure. No problem. I'll do that. I'll just close it and I'll do it again. Yeah, so label is basically here. So even without label you can do. So labeling is here. You can see label net. I just clicked on that and entered the value, say as V in, and I change the port type to input since I am adding on the input side, and I'll get the label here. If I go and click on this wire, the label will be there. Even without label you can do, you need to just click and see what is the name of this. It is basically, they will, the default name is VN001 or something like that. One more thing you asked, what is that?
So like the current you chose was L1,
yeah.
right? IL1, right?
I of V1. So I'll do that. So what you need to do is you have to run. When you click on run, this blank window will come. Right click on this blank window, add traces. You have V in that has come here. I just entered a divide sign here, and then you have I of V1.
So what's the difference between I of V1 and I of L1? Like the phase or?
Yeah, I didn't check that because what I need.
Right?
Yeah, the current should be same here. Yes. What I need is at this point, so I just have taken I of v1, and that will give you the plot. And you can just remove the phase plot so that it will be clear. That is by right-clicking on the right side, then left-click on left side, and then change this to linear, so that you will get in ohms. That's it. Is it clear?
Sir, and where do you get the voltage source?
Yeah, voltage source. See, okay, I'll explain few things here. You can see this is wire, this is a ground button, this is label. These are 3 components available directly with the diode, and all the other components are here inside this. You can see this and symbol, right? Here you will have a lot of components. Only one voltage is available, that is at the end. Is it clear?
Yes, sir.
Sir,
Yes.
so how did you change the value of like the y-axis from dB to ohms?
Yeah, I'll do that. Just click on this run, take the plot, V in by. First, right click here, you will see a scale on the screen, right click, and just click on don't plot phase. Then again, bring the cursor to the left hand side, you will see a scale again, right click there, change it to linear.
Okay, okay, thank you.
Yeah.
So after using that cursor to find the vertical line, would you call it the trace? I'm not able to enter the value in the dialog box to the exact size.
That option
we can't
is
do
not
that,
there.
right?
We can't do that.
Okay, fine.
At least I'm not able to do in my system. Usually, I thought that option will be there, but that was not there in my system when I was doing it.
Okay, sir.
Yeah. So with this, I am just winding up this session of LTspice demonstration.